Hi there, and welcome to this video where we get to deal with the exercise questions associated with the part where we talked about dilution and molar concentration. So we have the first section, which is the basic part. Before we move on to the intermediate and advanced parts, let's handle the babies in the room. So we have the first section or the first question that says, find molarity when 1 mole is in 2 dm cube. Okay, so we know that molarity M is equal to the number of moles of the solute contained in the volume of the solution in dm cube. So let's plug in our values, okay? The number of moles is 1. The volume in dm cube is 2. So therefore, the molarity becomes 1 divided by 2, which is 0.5 moles per dm cube. Easy peasy. Number 2 says convert 250 cm cube to dm cube. So how do we do that? To convert from cm cube to dm cube, what we simply do is to divide the volume in cm cube by 1000 because 1000 cm cube is what makes 1 dm cube. So that explains why that division is necessary. So in order to carry that out, let's simply do our division. To convert 250 cm cube to dm cube, we have 250 divided by 8000. This gives us 0.25 dm cube or 0.25 liters. Whichever one you choose is absolutely fine. So that being said, let's move on to the next section that we are dealing with, the intermediate section. So we have if concentration is 0.2 moles, okay? What concentration rather? If what is the concentration if 0.2 moles dissolved in 500 cm cube? Molarity is always equal to the number of moles all over the volume of the solution in dm cube. Now, the number of moles, 0.2. The volume is 500 cm cube. So here is a problem. The volume was given in cm cube, but we need it in dm cube. So what do? We simply convert from cm cube to dm cube. And how do we do that? We divide the volume in cm cube by 1000. 500 divided by 1000 gives us 0.5. So therefore, we can plug in our values because this becomes 0.5 dm cube. So let's plug in our values now. Molarity becomes the moles, which is 0.2, divided by the volume in dm cube, which is 0.5. So punching our calculators, we have 0.2 divided by 0.5, and that gives us 0.4, basically. 0.4. Don't forget our units, 0.4 moles per dm cube. Easy peasy. Now let's move on to the final one. The final section of questions starts off by saying in titration, the acid and the base react in a ratio 1 to 1. Okay, what this simply means is that 1 mole of the acid reacts with 1 mole of the base. Okay, so in a titration, acid and base react in a 1:1. 25 cm cube of acid of concentration 0.1 mole per dm cube neutralizes an unknown volume of the base of a concentration 0.2. Find V. V here stands for the volume of the base. So let's put down the formula. We know that the formula for this is M1 V1 divided by N1 is equal to M2 V2 divided by N2. Now let's give names to each of these variables. M1 stands for the molarity or the concentration of the acid. V1 stands for the volume of the acid. And then N1 stands for the number of moles of the acid that reacted. And then we have M2. M2 stands for the concentration of the base. V2 stands for the volume of the base that was used, and then N2 stands for the number of moles of the base that reacted. So all these being put in place, let's go ahead and plug in our values into the formula. We know that M1 V1 over N1 is equal to M2 V2 all over N2. So M1 is equal to 0.1 moles per dm cube. Acid of concentration 0.1 moles per dm cube. So we have 0.1 times, they said 25 cm cube of acid. So let's write that down. Times 25 divided by the number of moles of acid that reacted is 1 because we have the ratio here, 1:1, which means 1 mole of the acid reacts with 1 mole of the base. So this becomes equal to M2. M2 stands for the molarity or the concentration of the base. The base of concentration 0.2. So let's put that down. 0.2 times an unknown volume of the base. Remember, they said neutralizes VCm cube of the base. So we don't know what the volume is. So let's just put multiplied by V divided by the number of moles of base used was also 1 in this case. So at this point, we have 0.1 multiplied by 25. 0.1 multiplied by 25 gives us 2.5. So we have 2.5 over 1 is equal to 0.2 V over 1. At this point, we can cross multiply. When we do, we have 0.2 V is equal to 2.5. So at this point, we are looking for V. So we simply divide both sides by the coefficient of V, which is 0.2. So this cancels this. V is equal to 2.5 divided by 0.2. 2.5 divided by 0.2. That gives us 12.5. 12.5. Now, what would the unit of the volume be? From the question, we can see that volume was measured in cm cube. So we simply put our number C, or our unit rather, cm cube, as simple as that. So the volume of the base used was 12.5 cm cube. And then finally, we have this question that starts off by saying, if 20 cm cube of solution contains 0.01 mole, calculate its molarity. Molarity will always be equal to the number of moles of the solute divided by the volume of the solution in dm cube. The number of moles is 0.01. The volume in dm cube, we're given 20 cm cube. So it means we'll have to convert this into dm cube. And to do that, we divide by 1,000. 20 divided by 1,000 gives us 0.02 dm cube. So let's plug in our values. We have 0.01 divided by 0.02. So 0.01 divided by 0.02, what does that give us? It gives us 0.5. 0.5. What would the unit be? We calculated molarity, and molarity is measured in moles per dm cube. That is the answer to all the sets of the questions. I trust you enjoyed every bit of what we just carried out. It's been an excellent and a jolly ride for me, and I trust it was for you too. Up next, we're moving on to the next topic in mole concepts, which is the rapid revision. We're going through all that we've talked about since the commencement of this series, and I look forward to seeing you in that video. I enjoyed this, and I hope you did too. With that being said, I will see you in the next video.